Hi guys, welcome back. In this video, we're building something very interesting. We're building our own cache using Golang. So you must have heard about Redis and Hazelcast and the way they save time and save operations by not letting your backend call your database again and again and caching and storing that information for small periods of time. So that's what we're building. So we'll try to build a full-on cache, but we won't be building the operations. A lot of operations are required to maintain a cache, and we'll have to get into a lot of algorithms. But we'll be using just data structures. We'll just build the cache, and we'll build some operations and adding and deleting from the cache. But we won't build the advanced operations that are required, the algorithms that are required in the cache. This is an intermediate level video. It's not an advanced video. It's not a beginner level video at all. So if you're very comfortable with Golang, very comfortable with pointers and structs and all those different concepts, this is the right video for you. So you'll get to build your own LRU, least recently used cache, using linked lists, which is a data structure in Golang. All right. So if you can see my screen, so I'll take you through the entire project as in what we're about to do, but let me show you what it looks like. So if I run, so I'll say go run main.go. What happens here is it's taking some values like cat, blue, dog, tree, and dragon, and it's creating this queue out of it, queue, and the queue is the cache in our case. And let's not get bogged down with all this that you see on the screen. Let me first explain to you what's going to happen. So we'll have a cache. I've demonstrated that using this kind of like a rectangle. So it maintains a specific length of items. So this length of items we can always keep changing based on our preferences, but let's say it maintains a specific length of items, and it's called the LRU cache. Only the most recently used items will be kept in that cache. So there's an LRU cache, and then there's a true LRU cache. If you read about it more on the internet, that for a true LRU cache, which we are going to build, there are these three conditions that need to be met. The first is if an item already exists in that cache, we need to remove it and add it again to the beginning. So let's say the cache is there and already has a lot of values. So again, that value comes into the cache. That means you have to check, and then you have to find that value in that cache. You have to remove it, and then add this same value in the beginning of the cache, so that it stays least recently used, right? It stays recently used, and you can access it. So because all the old items are going to be removed anyways. And the second condition is an order of the items needs to be maintained. You can't just store them like a big data object without any order. You have to have an order of these items. So that's another criteria that needs to be met. The third is the deletion happens at the tail mostly. So we can delete items from between the cache also, which I'll show you how to do that. But mostly the deletion happens only at the tail, and the addition to the cache happens only at the head. So there'll be head to this cache, there'll be a tail to this cache. Almost like we'll have a queue and we'll have a head and a tail. So from this side, the addition, you can see the item goes in. But from this side, the end, the item goes out when the capacity is full, right? The capacity obviously depends on the specific length of the items that we specify for that cache. Anyhow, now the cache is made up of a queue, and the queue is made up of multiple nodes. This is very similar. Actually, it's the same concept as a linked list. So in a linked list, what happens is you have a node, and then you have a left and a right. And the left, and also there's a node at in the middle. Now the left stores the address to another node, right? Which will be basically on the left. So whatever node will be on the left, right, of this list to create the queue, of this node to create the queue, the left variable will store the address, and the right variable will store the address of the left and right nodes respectively. All right. Now it's quite possible that you still not understanding much. It's not a problem. When we'll start coding, everything will start making a lot more sense to you. And then we have a concept called as the queue. Now queue has three things. One is the head, one is the tail, and the other is the length. Length is the integer of the number of items in the queue, and head is basically an empty node. So this node is going to be a struct, right? It is going to have three things: left node and right. And then node itself is going to be a struct, and then the queue is going to be a struct in our project, which will have a head, which will be a node, and a tail, which will be a node, and these will be empty. and these will just contain, the head will always contain or always point to the first element in the queue, and the tail will always point to the last element in the queue. So the tail, since it's a node, as you know, whenever you look at tail, it's a node. You already know that it has left node and right, these three things. So that means the left of the tail will always point to the last element in the queue, and the right of the head will always point to the first element in the queue. All right, so that forms up our queue. Now we in our cache, along with our queue, we also have one more thing called the hash. So hash is the map basically, and it has a text. Text will be the values that we'll send it. So all these values that you'll send, like blue, cat, and all of these things, these will be the text or the strings, and then they will have a node associated to it. So we're just maintaining all of that in a hash basically in the cache. So if you want to add something to your queue, right? So like I said, you know, it will only go from it will only be added here at the beginning of the queue, which is the head of the queue. To add something, what you'll have to do is you'll have to point the right of this particular node, the new node that's coming in, to the first element of the existing queue, and the left of this node will point to the head of the queue, and then automatically this new element will be added to the queue. All right, again, I'm saying that if it's not making much sense, if it's all looking very confusing, when we'll code, we'll go through these diagrams again and again, and everything will start making a lot more sense to you. Now, to delete an item from the queue, so we have to take into account two different scenarios. One is that the element is deleted from the last place, which is the tail, or the element is deleted somewhere in between. So like I said, you know, I'd said that the deletion happens at the tail and addition happens in the beginning. So in the beginning the addition happens, and when we'll exceed the limit of the cache, the last element of the cache will be removed, right, as the node. So when it's removed from the as a node, it will be removed at the tail at the end. But then sometimes what's happening here is that like I said, the criteria for the least recently used cache is that if an item exists, we need to remove it and add it to the beginning. So the item could exist somewhere in between the queue, and we may have to remove it and add it to the beginning of the queue. So so we'll have to have a scenario that also helps us to delete items from the middle of the queue as well. So what we'll have to do is we'll have to basically come up with a very common kind of formula or a way to basically remove elements from the cache. So what we're going to do basically is whenever we have to remove some node from the cache, we'll point our right so we'll take that node, like this node has to be removed. All right, so this the node to the left of this node that has to be removed, the right of this node will point to what this node's right is pointing to, which is basically this node, right? Node 3. So I'll say 1, 2, and 3 to make it more clear. So the nodes, so the first node's right needs to be pointing at what the second node's right is pointing to currently, and the third node's left needs to be pointing to what the second node's left is pointing to currently. So that means if this points to this and this points to this, then automatically second gets deleted because nobody has address of second anymore. So automatically it's deleted from memory. So that's going to be a deletion. Now, again, like I said, you know, it might not make much sense to you. Maybe you're very new to data structures. You have no idea what linked lists are. Not a problem. We'll go through them one by one again and again. So what I want to do now is I want to create a project. All right. So I'll come back to my workspace and I'll create a new project. I'll say mkdir and I'll say cache project. All right, so we'll cd into it, and we'll also say go mod init github.com/akhil/cache project. Go mod init if you are new to Golang. By the way, if you're new to Golang, then this is probably not the right video for you. But anyhow, if you're new to Golang and if you're seeing this video for the first time, then go mod init basically is like, if you're coming from a JavaScript background, then go mod init is like npm init. It creates a package.json kind of a file for you. So it created a go mod file, which is like package.json file basically. And what we'll do is, so this file, the go mod file, creates holds a list of all your dependencies of your project. In our project, I don't think we'll have any external dependencies. So let's go ahead and open this project. Let me bring it onto the screen so that you can see it. And here what we'll have to do is we'll have to create our main.go file, where at the beginning we'll say package main, and then we'll import a couple of things. For now, let's just import fmt, and then let's create our func main. So in our func main, all we're doing is we are just writing fmt.println start cache, and we're creating a variable called cache, and we'll have a function called new cache. We'll just initiate the new cache for us. And then what we're going to do is we're going to say, we'll use a for loop, and we'll take a slice of strings, and here we can enter our input, so all the element that we want to add to our cache. All right, and then there will be so all these elements will be here inside this slice of strings, and then we'll go over them one by one, and then all of those values can be accessed using this value called word. And then we want to have a function called check. I'll explain to you why we need this function. And then we have another function called display. All right, so these two functions are what you need to keep in mind. And here you'll just enter the list of all the things that you want to enter into the cache. So for example, we want to say parrot and avocado. I'll just put some random values. All right, parrot, avocado, and we will say dragon fruit, and let's say tree, and potato, tomato, we'll say tree again, and dog, any random stuff. Anyways, so those are the things that you want your cache to process and store. All right, now let's try and create like an outline of the project. That based on the diagram that I showed you, there needs to be an outline of the entire project. So that means that we'll have a struct called node, okay, so let me show it to you on the diagram also. So the struct called node is this. It has something called as left and right, and it has a node. All right, so that will be our struct called node. And then you'll have a struct called queue. Then you'll have a hash map, which will be string, and it will have a node associated to it. So it's capital N because that's what we've written here. So queue and hash map, right? So as you can see, we have a queue which will have a head, tail, and integer length, and we have a hash map which basically has text, which you just saw, string, and then it'll have a address of the node. So that's what we've done till now. Okay, and then we have our cache. So like I told you, the cache has two things. It is basically queue of type queue, and it has a hash of type hash. Quite straightforward. And then we're calling this function called new cache, so we'll have to have that function called new cache, function new cache, and it'll return a cache. and then we'll have a function. So inside this function, right, we're just going to return a cache, which will basically be a queue, where we'll have a function called new queue to create the queue for us, and we'll have a hash, an empty hash, right? So hash can obviously call this struct, is type of the struct, right? Hash, it's an empty struct of type hash. That's what hash is. And queue is going to be created in a function called new queue. So now let's create, let's work on that function. So we'll say func new queue, all right, and we'll have something here. We'll have the queue here. So now let's go one by one and start creating all of our structs. So the node struct has a value of type string, which basically is the value here. So instead of node, you have to write value. So it'll have a value here of type string. It'll have a left, which will reference a node. It will have a right, which will reference a node. Okay, so on the left we'll have referencing a node, points to node, and the right points to a node to the right. All right, so that's what we are storing in one particular node. That's what we're doing. So our node is complete. Now our head, our queue, has a head which is of type node, and has a tail of type node, and it has a length of type int. And where did we see that before? This is the queue. It has a head of type node, so it has an empty node that points to the first element of the queue, which we'll get that to that later on. It has a tail, which is an empty node, and then it has a length. All right, so far so good. Now I think we should work on our new queue function. So our new queue function takes a variable called head, and takes an empty struct of type node, and it has a tail, again the address of an empty node, okay, and then we'll take head. So I'll write something and then I'll explain to you what's happening here. It's very, very simple actually. Okay, so let me draw it for you actually. Let me draw the diagram for you so that you'll understand more visually, basically. So if you have no elements here and only the head and tail are present, so we'll say head and we'll say tail, right? So in a queue we have these two empty things, head and tail. Now the right of this head, if it points towards the tail, and the left of the tail points towards the right, that means that the queue is empty because there are no values in between them, because the head and tail will always be empty. And head and tail we're just maintaining to basically always the head will point to the first element of the queue and the tail will point to the last element of the queue. That's why we're maintaining these head and tail in a queue. So if they point to each other, then that means that queue is empty, right? And that's how you initialize a queue. So that's what's happening here. So the right of the head is pointing to the tail and the tail's left is pointing to the head. Very simple. So all we have to do is return a queue here, the head of which is the head and the tail of which is the tail. All right, now if you notice something in a queue, the head has a capital H and a capital T, which basically you're returning, and but it's equal to the small h head and the small h tail, small t tail, right? So which is basically what we're defining here. So that means we have met the criteria of this being a queue, and we have created a proper queue, and that's what we're returning from the new queue function, which goes to the new cache function, and it takes the queue and the hash at the same time, and that's what's happening. And now comes the most important part, where we have to start working on our check and display functions. Now display function is quite simple, so we can do that at the end, and I think we should work on the check function. Alright, so let's build the check function. So we'll say func cache. Alright, because it's a struct method for cache. If you don't know much about struct methods, then I suggest you check them out. They're an important concept in Golang. So here we'll take a variable called node, and we'll make it empty, struct of type node. And what you're doing here is how to explain to you. It's actually quite simple. So this check function, right, what it does is it just basically takes all these values one by one, because we're running a for loop, and these values one by one will go to this function called check. Now what we want to do in the check function is we want to see if that value already exists in that queue. If it exists in that queue, we want to remove that value and add it at the beginning. If it doesn't exist, we just want to add that value to the queue. That's all this check function is doing. All right. And why do we want to delete a value if it already exists and add it again? It's because this is a least recently used cache. So the values, if that value was used much before, we want it to be, since it's being used right now, so we want it to come to the beginning, because only the recently used values need to stay in the cache, and the older ones will get deleted. Okay. So that's what we're doing in the check function. It's very, very straightforward. So we'll say, since we're maintaining a hash in the cache, right? So we'll say if that value is present in the hash map. So the value is basically the string that you'll pass from this for loop. You'll pass strings one by one to the check method, method, okay, which is of type struct, cache struct method. And in this method, you'll get the string, and the string you're checking in your hash, in your cache's hash, you're checking if the string exists, if there's a node associated with the string, and if everything is okay, then what you do is you say node c.remove. So like I said, if it's already there in that cache, you remove that value. And if it's not there, you just take a variable called node, and you make the value of that node equal to the string. So as you remember, every node has something called as a value, so that value will become now equal to the string if it wasn't there in the in the hash. If it was there in the hash, you deleted it. If it was not there in the hash, you just created a node where the value is equal to the string. Okay, and all you have to do is c.add node. You just add the node to it, and then you also add that value to the hash. So we'll say string equal to node. Okay, so here by mistake I've used the walrus operator. You just have to use a normal direct regular is equal to. So it's giving you these squiggly lines because remove function is not there and the add function is not there. But we've already seen using this diagram how addition and deletion needs to take place, right? So let me explain to you again. The node that needs to be added to this queue, the right of that node will start pointing to the first element that was existing in this queue, and the left of this node will point to the head of the queue. and while deletion is the same, right, wherever it's not the same actually, because we want to be able to delete from the from between the values as well. So the left of 1 will, the right of 1 will point to the right of 2, and the left of 3 will point to the left of 2, right? So that's what we will do to delete a value. So it's going to be pretty simple. All right, remove and add functions are going to be pretty simple as well. So let's go ahead and create our remove function first. So we'll say func c cache and remove n, and it basically returns a node after removing it. So once you remove it, it basically returns you a node, and you're going to add that node once it's removed, right? So that's why we're taking this value into node. And if it wasn't there in the hash, then it's just going to create a node with that value, the string that you had passed, and at the end, the basic thing that's going to happen is it's going to add that node to the cache. So let's write our remove function. So we'll say fmt.printf remove %s new line. So printf, wherever there's an f like sprintf or printf, it helps you also to format your string. So this %s will be replaced by n dot value. N is the node that we're removing. So the value of that will be printed here. All right. And here we'll also have left is equal to n dot left. We'll take two variables, left and right, and we'll point them to where this node that has to be removed, to the left and right of that particular node. So we'll say n dot right. Okay. And we'll say right dot left is equal to left. Sorry, this is a capital R. Right dot left is equal to left, and left dot right is equal to right. So what's happening here is pretty straightforward. Like I've already explained, that the node that has to be removed, the left of that you take into a variable called left, and the right of that you take into a variable called right. And the left and the right of that left variable, the left points to the right and the right points to the left. So if 2 is the node to be deleted, then 1's right is going to point to 2's right, where 2's right was pointing, and 3's left will point to where the 2's left was pointing, which is 1, right? So 1 and 3 will start pointing to each other, and 2 will disappear. That's happening basically here. Okay, straightforward. And we'll reduce the length by 1 of the queue. And we'll use a delete function, which is a native function with Golang, and we'll say c.hash n.value. Basically, you remove that value from the hash and you return n. Okay. Now we have two errors. One is for the add function, other is for the display function. So let's build our add and display function as well. So we'll say func c star cache add n. Okay. So we're passing a node to the add function, and we'll say fmt dot printf. And dot value. We'll take a temporary variable and we'll point it to the current queues, where the head of the current queue's right is pointing, so which will be basically the first element, so that we have taken into temp. Alright, so we'll say c dot q dot head dot right. So the new place where the head of the queue will point right now will be the new node that we have passed. So what's happening is that we pass a node to be added to the add function, and then this this node now basically is what the head of the queue is going to point towards. All right, and then the current first element, which is this, where the head's right was pointing to, this is the current first element before we had added this node, will be taken in this variable called temp. Okay, so we'll say n dot left is equal to c dot q dot head, and n dot right is equal to temp variable, and temp dot left is equal to n. Okay, so what's happened here is the queues till here we're understood, right? So let me show it to you again. So with addition, what happens is that the right of this node needs to point to the first element that was already existing in the queue. So this element we took into this variable called temp. Alright, so we took this variable, this value, the first node in the queue, into a value called temp. Then we took the current head of the queue, and the right of that we pointed to this first element that will be now the first element, right? This node that we have said that will be added to this queue. So the head of this queue will now point to this instead of this, right? Instead of this element, instead of this node, it's going to point to this node. All right, and the nodes left will point to the head, and the nodes right will point to temp. So what's happening here is the nodes left will point to the head element of the queue, which is the first the head element of the queue, and the nodes right, this new nodes right, will point to the first element, which was previously the first element, right? So this will now truly become the first element of the queue. Okay, so straightforward. If you if you've not understood this and if you're finding this confusing, you can always put that in the comments below and I'll try to explain to you. What I'm trying to do is I'm trying to explain every single line by going and showing the diagram for every single line, and I'm not sure, but I'm still not sure if I'm able to explain it to people who don't have a background with data structures, because data structures are quite important. I hope I'm able to explain it, but if I'm doing a bad job, then let me know and I'll try to explain to you on a personal call if you want. And what we'll do is c dot q dot length. So if you add an element to the cache, right, you will have to increase the length, and if we were deleting something from the cache, we were reducing the length. So here you're increasing the length, and we're doing one more thing. So while adding something to the cache, we're also checking that if the size of the cache has gone beyond what we had defined. So what we'll do is we'll take a variable called size. So after our import, we'll say constant size is equal to 5. So this means that this is the size of our cache. The size of our cache needs to be 5. And here what we are saying is, in our new add new function, we are saying that if the length of the queue dot length is greater than size, so we've gone beyond the size that was given to us, then we have to remove something from the end. So we'll say c dot remove the last element, which is c dot q dot tail dot left. So the tail of the queue, the left of the tail of the queue is pointing to the last element, as you recall. So that last element of the queue needs to be removed if we have already exceeded the size of the queue after this addition function has happened. Now all we are left to do is create this display function. So this display function basically takes a cache, right? So we'll say func cache display this display function is of type cache. It's a cache method. So we'll say c dot q dot display. So to display the queue, now queue dot display doesn't exist, right? So we'll have to create it. So we'll have to create a display method for the struct which is queue. So we'll say queue star queue display. So this display method is of type cache struct, and this is for queue struct, right? So we have two different structs for cache and queue. So basically our cache display method calls our queue display method. So that's what this is doing. And so we'll take a node, so queue dot head dot right. So this means the right where the head of your queue, the right of that is pointing, that is obviously the first element in your queue, right? So you'll take that in node, and then you say fmt dot printf %d and this is where we'll start, and comma queue dot length. So we'll print out the length out there. The length of the queue needs to be printed first, and then we'll say for I not equal to 0, I less than queue dot length I plus plus. So we'll run a for loop. We'll say fmt dot printf %s comma node dot val. So this basically helps us to print the node's value between those curly braces, as you'd seen in the beginning of the video. If I less than queue dot length minus 1, then we'll say fmt dot printf so node is equal to node dot right helps you to point to the next element, right? So one by one you can keep pointing to the next element. So since you're in a for loop, right? So node is when node becomes node dot right, that means right and then right and then right again. You can keep going to the next element very easily. And here you'll say fmt dot print ln. So these brackets, this bracket and this bracket, you'll understand once we run this code. It's just for formatting, and these curly braces are also for formatting, and then this %s basically gets replaced by node dot value. The value gets printed here one by one, and that's about it. So nothing else is happening here. And let's try running this code, and there could be errors, which I'm pretty sure there will be errors. So let's say go run main.go, and wow, there are no errors and everything works perfectly. And what's happening here is that first you added parrot, so the length is printed out here. The length of the node is printed out here. This one, the bracket is printed, and then the length of the node is printed. So let's see the bracket is printed and the length of the node is printed, and then inside that bracket we have our parent, the first element, which is node.value, right? So one by one it'll keep going through all the till the whole complete length of the queue and print it out. And here the length of the queue becomes 2, and then it prints out these 2 values. Length of the queue becomes 3, prints out these 3 values. And what's happening here, it's adding tomato and removing parrot, because when you add potato, right, you reach the length, which is 5, which is the maximum length allowed to this cache. But when you try to add tomato, it will have to remove the last value from this cache, right, from this queue. So it'll remove parrot from there. So now you have these values. Now as you can see that tree is already a value that exists. So when you try to send tree here again, so it'll remove tree and then it'll again add tree to it. So then the latest elements are maintained basically. Then you add dog and remove avocado. Avocado is the last element, you remove it and then you add dog to it, and that's when you get this basically. And that's how our queue is working. Let me take you through the entire code again. So what's happening in our func main is we start our cache, and then we have a list of these values that we want to put into our queue. And one by one, since we have a for loop running, one by one, all these values will be iterated through, and then we'll call this function called check, and then we'll call this function called display. And both of these functions are of type these are methods for the cache struct. So for the check function, what happens is you go to check function. In the check function, you create a variable called node, which is an empty struct of type node, and you check if that value, that string that has come into this function, already exists in our hash for the cache. Now the cache basically consists of a queue and a hash basically, right? So in the hash we are checking if that value exists. If it exists already, then you remove it. If it doesn't exist, then you try and create that value. But even after you've removed that value, you want to add that value, right? So if it didn't exist, then you'll add it, or if it existed, then you remove it and then you add it in the beginning. So the add function, all it does is it adds any value to the beginning of the queue, and the remove function basically removes a value from the queue, and display basically displays it very simply, right? So every single time you're adding something to the queue or deleting something to the queue, you're printing out or displaying the entire queue again and again, and that's what's happening here, right? So every single time the display function will be called. Now this node has a value, a left and a right, which you've understood. So every single node will have a left, which will point to the left another node, the right will point to another node, and the queue will have a head and tail, which are empty nodes. And the head basically does the work of pointing to the first value of the queue, which will be a node, and the tail does the value or the work of pointing to the last value of the queue, which will be again a node, right? So that's what basically our entire project is. Now it's quite if you were already familiar with linked lists, then everything will be much simpler to you. But in case you don't have an idea about what linked lists are and how data structures work, then obviously all of this will be very difficult for you. And if you didn't understand anything in this project, then do let me know, and I'll try and explain it to you. If you have any issues in the comments, then do let me know. So thanks a lot for watching, and on this channel we'll have a lot more videos coming up with Golang. So, and I'll see you in the next episode, and do stay subscribed. Thank you.